This demonstration is to explain the basic principles of conservation of energy in a closed system. For today, we will be analyzing the energy possessed by a skateboarder while going down and up a ramp without any applied forces. Now, before we start, we must keep in mind this is only possible in closed systems when we don't take into account air resistance, wind, friction, or other external forces. During this video, please remember these following basic equations to help us calculate the mechanical energy. In this situation, the ramp has a height of 4 meters, the skateboarder has a mass of 70 kilograms, and the skateboard has a mass of 4 kilograms. When the skateboarder is on top of the ramp, his total mechanical energy is 2,900.8 joules. This energy consists of just gravitational energy since he is above the reference point. Since he is not moving yet, there is no kinetic energy present at that position. So the total mechanical energy just consists of potential energy of 2,900.8 joules. As the skateboarder goes down the ramp due to gravity, he starts to lose potential energy and gain kinetic energy. This is because his height relative to the reference point is decreasing, which is also decreasing the potential energy. But at the same time, since the skateboarder is moving, he is accelerating and building up speed, so his kinetic energy starts to increase. For example, at the halfway point down the ramp at 2 meters, the skateboarder has an even amount of potential and kinetic energy. And take into account that the sum of the energy stays the same even though the position is changed. This is because some of the potential energy just transferred and changed into kinetic energy as he went down the ramp. So now, he still has 2,900.8 joules of mechanical energy, but there is only 1,450.4 joules in potential and kinetic energy each. By the time the skateboarder has reached the bottom of the ramp, all his energy is transferred into just kinetic energy. This is because there is 0 meters height at the bottom, so there is also 0 potential energy. Whereas there is only kinetic energy because this is the point where the velocity is the fastest. The amount of energy still remains constant, but has just transferred into kinetic energy. So now there is 2,009.8 joules of kinetic energy, and 0 joules of potential energy. As Newton's first law states, an object in motion stays in motion, the skateboarder would also do the same thing in a closed system. He wouldn't just stay at the bottom, inertia would make him go back up the ramp. So as the skateboarder travels back up the ramp, he starts to slow down because now that he is gaining height, his potential energy starts to increase and his kinetic energy starts to decrease. If the skateboarder is back at 2 meters, then both kinetic and potential energy would be evened out at 1,450.4 joules each, yet their sums would still remain constant at 2,900.8 joules. Finally, as the skateboarder goes all the way up the ramp, he only possesses potential energy again. This is because for that one moment when he's back at the top of the ramp at 4 meters, his velocity is 0 meters per second, also making his kinetic energy 0 joules. So now, all his 1,450.5 joules of kinetic energy has been transferred into potential. In total, the skateboarder still has 2,900.8 joules of mechanical energy. In conclusion, you must remember that in closed systems where there are no external forces, mechanical energy always remains constant. The energy may just be transferred from one form to another, but no matter what position the object is in, the sum of it will always stay the same. However, in real-life situations this is not possible. For example, if in reality the skateboarder were to go down a ramp, they may not be able to go back up a ramp because some of their energy may have been transferred to heat or sound energy. There is also friction on skateboard ramps, so more energy would also be transferred to go against the friction. Therefore, in real situations, the mechanical energy doesn't always remain constant since it is transferred.